Good evening to you all. Waiting for the class. Only 6. It's exactly 5 o'clock. I will start my class. Going back to yesterday's discussion, we have the probability of getting the events favorable with total possible outcomes in different aspects. Yesterday we discussed regarding tossing a coin, tossing of two coins, rolling a die, rolling of two dice. And apart from that, we have the discussion about the number of balls in the basket, what is the probability of particular color, and probability of getting 53 Sunday, Monday or any day of the week with respect to leap year and non-leap year, and regarding the probability of getting vowels and consonant from the English alphabets, and also probability of getting an vowel from the given word. We have to take off the each letters as total possible outcomes favorable with respect to the condition mentioned. Now today we discuss about what is the total possible outcomes when three coins tossed. Then regarding the playing deck of playing cards, 52 cards. If I explain that, then based on that we can complete today's worksheet. Today's worksheet consists one set of MCQs that you can easily answer. The remaining questions I will answer. Okay, listen the explanation. Later you can work out, because here all just is explanation. If you get a concept, any such problems you can easily answer. So when we toss a coin, there comes only two outcomes, head or tail. When we toss two coins, you have 2 to the power of 2. That is 4 possible outcomes. 2 to the power of 1. Only one coin, you have two chances. 2 square, 4 possible outcome. That is HH, HT, TH, TT. When we toss three coins, this tossing of three coins is not in your textbook part, but still you will get a question based on that. Instead of coins, they may give that children, three children, children, what is the probability of getting a boy only? At most one boy. All those conditions based on the coins. Instead of coins, they will make use of these children in a family. So now when three coins are tossed, we have 8 possible outcomes. 2 to the power of 3, 8 possible outcomes. Which are those? When three coins are tossed, tossing of three coins simultaneously, tossing three coins in different times with different persons gives the same result. We accept that 8 possible outcomes. That is, we cannot hold all the three coins, making three persons to toss it simultaneously. Then we will search out the conditions, whether you will get head, tail, head, like that. You have total 8 possible outcomes, which are those: H, 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 T, H, T, H. Then T, H, H. Then T, 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 H, T, H, T, H, T, T. Total 8 possible outcomes. So now when we put a question, What is the probability of getting 3 heads only? There is only one chance of getting a favorable as only one chance. All the 3 heads together. So the probability is 1 upon 8. What is the probability of getting exactly 2 heads? You have 1, 2, 3. Only 3 chances to get exactly 2 heads. At most 2 heads. At most means 2 head is maximum. Then we consider 2 heads, 1 head and no head. That is 1, 2, 3. 4, 5, 6, 7. At most 2 heads. At most means that is the maximum. At least, at most, got the difference now. At least 2 heads means you may get more than that. What I given the before, it is at most 2 heads means 1, 2, 3 and 1, 4 by 7. At least means you'll have 1, 2, 3, the remaining will continue, will satisfy so that you'll get 7 upon 8. At least, at most. Is clear? Like that, what is the probability of getting exactly 3 tails? You have only one chance out of 8 possible outcomes. Like that, we can frame number of questions based on this tossing of 3 coins together or simultaneously. Next, in an event called deck of 52 cards. Total number of cards is 52. 52 cards. We have club, spade, heart and diamond. Club, spade, heart, diamond. There are 4 types. 2 are black in color, 2 are red in color. Each has 13 cards. That is, each suit has 13 plus 13 plus 13 plus 13. Together it is 52. Among each suit you have, we call it as black suit and red suit, you have 3, 10. 3 face cards, 10 numbered cards. Like that, 3 plus 3, 6 black face cards. Then 6 red face cards. Is it clear? These 3 face cards are King, Queen and Jack. King, Queen and Jack of club, which are black in color. Similarly, King, Queen and Jack of spade. It is also black in color. Similarly, King, Queen and Jack of heart is red in color. Similarly, King, Queen and Jack of diamond is also red in color. So now 3 plus 3 plus 3 plus 3, 12 face cards. So out of 52, we have 12 face cards. The remaining cards are 10 plus 10 plus 10 plus 10. It is 40. We call it as non-face cards. Or we can say that numbered cards. Non-face cards. Face card, non-face cards. 12 face cards, which are King, Queen, Jack. Each of set consists 3 plus 3. So 2 black king, 2 red black queen, 2 black jack. Similarly, 2 red queen king, 2 red queen, 2 jack. This is red in color. Altogether, you have 12 face cards where 6 are black in color, 6 are red in color. Is it clear? 6 are black in color. They are 2 plus 2 plus 2. That is 2 black king, 2 red king, black queen, 2 black jack. Remaining 2 red king, 2 red queen, 2 red jack. Remaining out of 40, you have 20 non-face cards which are black in color, 20 non-face card which are red in color. So 20 plus 20, 40 non-face cards or numbered cards. Is it clear? I will explain it once again. A deck of cards, a pack of cards consists 52 cards. A deck of cards consists total 52. With that, you have 4 different types. They are club, spade, heart, diamond. Club and spade are black in color. Heart and diamond are red in color. Each suit, we call it as black suit, red suit. You have 26 black suit color cards, 26 red color cards. Among 26, 13 from club, 13 from spade, 13 from heart, 13 from diamond. So now if you take out the face cards, each suit consists of 3 plus 3, 6 face cards which are black in color, 3 plus 3, 6 face cards which are red in color. Remaining 20 are non-face cards, 20 are non-face cards which are black in color as well as in red in color. So while giving the question answer, we have to think which colored card has been removed, to which they are asking the favorable. And suppose if the few cards are removed, what will be the remaining cards? After removing the cards, the remaining cards will be the total possible outcome. So don't consider that in always you will have the total possible as 52. Suppose in question they will give up all the red face cards are removed. How many red face cards you have to think? It is 6 red face cards. So out of 52, 6 are already removed. The leftover remaining cards will become the total possible outcomes. Later you have to identify the favorable number of cards which is mentioned in the problem. Then you have to write the ratio as its probability of an event. Is it clear? So here you have to think whether it is left, whether they have taken only the spade, whether they have mentioned only the black suit colored cards or red suit colored cards, whether they have taken either or including the cards or either or neither. All the words in the statement mentioned, it's very important to get the favorable. Here probability problem, if you get answer it is correct only. If any mistake you won't get the marks. You are written halfway not like that. They will see the probability. With all the condition mentioned, you have to complete the answer. Is it clear? This is regarding tossing of 3 coins simultaneously. This is regarding a deck of cards, playing cards. Total 52. You have 4 set, 2 are black suit, 2 are red suit. It's clear? Now here comes the problems. First I will go back to yesterday's probability where I left some of the questions. We clarify, then I will go on to today's probability sheet. Yesterday I left some problem. Okay, I will write this detail also here so that you can analyze. That is 52 cards. These 52 cards has been divided as club, spade, diamond, heart, 13, 13, 13, 13, 3 plus 10, 3 plus 10, 3 plus 10, then finally 3 plus 10. So you have 12 face cards and 40 number cards or non-face cards. Okay. Now, here is the question number 5, yesterday's worksheet. That is, a card is drawn at random from a pack. They will mention the word always the random. That means without knowingly, just shuffling the cards, they will pick up it without identifying which card they are removing. It is called as a random experiment, unbiased, bias like that. Random experiment. Random. Find the probability that the drawn card is a king of jack. So here you should analyze there are total 52 cards. Among them, a king of jack they are given. A king of jack. Jack king is present in red suit as well as in black suit. You have one each in each type. Club has one jack, diamond has one jack, spade has one jack, and heart has one jack. All together you have a king of jack. It's not king of jack. It is a king of particular word they have to mention. It is not king of jack. It's a mistake only. Card of spade like that. It's not a king of jack. We consider it is a king of spade or a diamond. A diamond consists of one king because jack is also one of the face card. We cannot get a king of jack. It should be a king of any type we can. So we consider a king of diamond. Then the answer is probability of getting a king of diamond, which is red in color, equals favorable outcomes by total possible outcomes. Diamond has only one king, so you write 1 upon 52. Next, card of spade or an ace. You have total 13 spade and a card of spade or an ace. This card of spade is already one ace. Remaining 3 you have to consider. It's clear? Probability of getting a card of spade or an ace. Total you have 4 ace. Ace is the number 1 card. So all the 4, but 1 is already included in the spade. So you have favorable outcomes as 13 plus 3 because out of 4 ace, 1 ace is already in spade. The remaining 3 aces from club, diamond and heart. So favorable is 16. Total possible outcomes is 52. So its probability is 16 by 52. 4 fours are 4 13s are 4 by 13. Is it clear? It is spade or an ace. Spade consists 13 cards. In 13 cards, 3 face cards, the numbered cards start from 1. The number 1 is called an ace. In old textbook, they used to include ace is also a face cards. Now, according to the present textbook, you have only 3 face cards, that is king, queen and jack. Next, neither a red card nor a queen. Third one, probability of getting neither red card, neither a red card or nor a queen, nor a queen. A red card consists already 1 plus 1, 2 queens. Remaining queen is from the black suit. Total number of red cards here is 13 plus 13, it is 26. Red cards are under heart and diamond. 13 plus 13. In both the suit, you have this queen, red queen. Or a queen is not included means plus 2 from the black suit. Total 28 cards. 28 cards, excluding those 28 cards, you have to find the probability. So now you will write probability of getting this equals 1 minus 28 by 52. This is one method, or subtracting 28 from 52. Directly you can write favorable by total. Here I use the relation probability of not an event equals 1 minus probability of an event. That is, suppose if the question, what is the probability of getting red cards or a queen, then 28 by 52. But here is the question, what is the probability of getting neither red card nor a queen? Averadu bittu, leaving those two. What would be the condition? So to that probability of not an event, we consider 1 minus 28 by 52. That is 1 minus 4 sevens are 4 13s are 13 minus 7 by 13. 13 minus 7 is 6 upon 13. Either means we include, neither means we exclude it. Next, an ace. Probability of getting an ace. P of getting an ace. You have 4 ace from each set. That is heart, diamond, spade and club. You have 1 plus 1 plus 1 plus 1. So you have the favorable outcomes by total possible outcomes. It is 4 upon 52. It is 1 upon 13. Because there are 4 A's, number 1 in each set of cards. Next, a non-face card. Face cards is total 12. Non-face card is 40. So probability of getting non-face cards. Getting non-face cards. Sometimes you will get the word as what is the probability of getting numbered cards. Non-face cards, numbered cards are one and the same. You have total 40 out of 52. You will get 10 upon 13. Here comes the way of presenting the probability with respect to favorable by total possible outcomes. So here onwards we'll have the discussion, but the final answer I will write, but all other steps you have to write as it is. Probability of getting favorable outcomes, total possible outcome. In some cases I will write all the steps, otherwise I will discuss the answer. While answering you have to include this, then write the ratio, then its numerical value you have to write. Clear? Next. Next question, question number 7. This is also based on the deck of playing cards. The queen, jack and 10 of spade. Queen, jack and 10 of spade. Number 10 from spade, queen and jack, all the three from spade. A spade consists of total 13 cards. With that, 3 cards have been removed from a pack of 52 cards. So remaining cards equals 52 minus queen, jack and 10. What you will get? 52 minus 3 is 48. I'm sorry, 49. Then a card is drawn from the remaining. Now you have to consider total possible outcome is 49, not with 52, because in the beginning itself they mentioned it has been removed. Now from the remaining card, well shuffled, probability of getting a red card. P of getting a red card. Red card here, spade, queen, jack are removed. King, queen, jack and 10 of spade. Queen, jack and 10 of spade are removed from the pack of. So here 10 of spade, queen, jack are removed. But the question is find the probability of getting red cards. Red cards together you have 13 plus 13. It is 26 upon 49. Then a king. Probability of getting a king. You have 4 kings from 4 set, so 4 upon 49. A black card. Since spade is black in color, total black cards are 13 plus 13, 26. But already 3 cards from spade has been removed, so the probability of getting black card equals, we write 13 plus 13, 3 removed means 23 by 49. Next, a non-face card. A non-face card you have total 40. Among that, a 10 is removed. King and jack are face card. Non-face card is 40. With that, one 10 card is removed. So the probability of getting non-face card equals 39 by 49. Next. Question number 10. A card is drawn at random from a well-shuffled playing card. Find the probability that the drawn card is a spade or an ace. You have done that. A spade is 13 and ace you have 4. Out of 4, 1 is already in spade. So 13 plus 3 is 16 is the favorable. Previous problem also the same question, so I won't write the answer here. Since a card of spade means 13 and or an ace, together 4 ace, 1 ace is already in the spade card, so 13 plus 3 is 16 out of 52. A black king, you have 1 from spade, 1 from club, 2 black kings out of 52. So the probability of getting black king is 2 upon 52. On simplifying, you will get 1 upon 26. Neither a jack nor a king. That means excluding you have to write neither a jack. Jack you have 4, nor a king you have another 4. Excluding that you have to proceed. That means probability of getting neither jack nor a king. You have altogether 4 plus 4, 8 cards. Excluding 8 cards, you have to find out the probability of an event equals 1 minus 8 by 52. That is 1 minus 4 twos are 4, 13s are 13 minus 2 is 11 by 13. Suppose if they mention either a jack or a king, then you have to write it as 8 upon 52. Neither means we will exclude those two cards. Next, either a king or a queen. Either a king means you have 4 kings, 4 queens, so altogether you have 8 cards. So the probability is 8 upon 52. Next is either, neither. Either king or a queen. You have 4 king, 4 queens. How 4 queens? You have 2 black kings, 2 red kings. Similarly, 2 black queen and 2 red queen. Together 8 cards out of 52 cards. Simplify, you will get the probability of an event. Is it clear? It's a logic question. You have to analyze what is required, what you have to subtract. On subtracting what result you will get, that will be the favorable. And the condition what they mention, whether it is a deck of cards or a set of conditions while tossing a coins, depending on that you have the probable total possible outcomes. Here comes today's worksheet. I hope that you are clear with this, how to write the probability. I'll give 1 minute time. Just go through that, then show me your thumbs up so that I can proceed with next set of problems. Okay? Next question. This is today's worksheet. A card is drawn at random from a well-shuffled deck of 52 cards. Always a pack of cards consists together number 52. Find the probability that the drawn card is either a spade or an ace. Either a spade or an ace. That means there are 13 spade and 3 ace, because 1 ace, the same type question you are repeated here. So together 16 upon 52. A black king, you have 1 from spade, 1 from club, you have 2 black kings out of 52. So the probability is 2 upon 52. Is it clear? Next. 3-digit numbers are made using the digits 4, 5 and 9 without repetition of the digits. If a number among them is selected at random, what is the probability that the number will be end with 9, a multiple of 9? That means, as we know that in 3 coins, we have the repeated numbers. That is H, 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 T, T, T. Excluding, remaining will be 6. Here also, you will get 6 such conditions. because they can rearrange the terms, not the repeating numbers. Among the previous, you have two conditions, H or T. The repeated versions are HHH and TTT. So now let us have the total possible outcomes. Total possible outcomes are 459, 495, 549, 594, then 5954, 945. 1, 2, 3, 4, 5, 6. Just to see, is there any possible number? Can we do 459? Just interchanging 495. Then 945 already taken. Again 549, 594, 954, 945. There are 6 total possible outcomes. Now the question is, what is the probability of getting number end by 9? Out of 6, what are the favorable outcomes with total possible outcomes? Favorable outcomes end with 9 is 1 and 2. So we write it as 2 upon 6, it is 1 by 3. You have one more question. A multiple of 9. Check out whether you will get how many conditions which are multiple of 9. Getting number multiple of 9. Can you check it? You divide each condition by 9. It will go by 9. Here it is go by 9. It is divisible by 9. Again it is divisible by 9. Yes, yes. All will satisfy to the condition which are divisible by 9. So the favorable outcomes by total possible outcomes, it is 6 upon 6. It is number 1, which is a sure event. This yesterday only we discussed the question number 3. 2 different dice are thrown together. We have total 36 possible outcomes. One along horizontal, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Together you have 6 cross 6. 36 possible outcomes. Okay. Out of 36 possible outcomes, the condition, sum of the number on each die is even. Yesterday only we discussed 2, 2, 2, 4, 2, 6, 4, 2, 4, 4, 4, 6, then 6, 2, 6, 4, 6, 6. So last class question only, you have one more sub question. The sum of the numbers appeared on 2 die is 5. That is 2, 3, 3, 2, 1, 4, 4, 1. There are only 4 chances. You have to write favorable with the possible outcomes ratio. There in the bracket you write the conditions which is satisfying the given question. That is, the sum is 5 means we have 1, 4. 1 plus 4 is 5. Reverse is 4, 1. 4 plus 1. Then 3, 2, 2, 5. Is there any other number whose sum is 5? No. So then you write there are 4 chances out of 36. Its probability is 4 by 36. It is 1 upon 9. Is it clear? Next. Number from 30 tickets, gets numbered from 2 to 31. So in that condition, number 1 is not included in the 30 tickets. It starts from, the tickets number starts from 2, 3, 4, dash, dash, 31, together 30 tickets. 31 minus 2 plus 1, you will get 30 tickets. Instead of counting 2, 3, 4, you will get the difference of last number with first, then plus 1 gives the total number of tickets. It is 30 tickets. With that, find the probability that it is a multiple of 7. After 2, the multiple of 7 starts from 7, 14, 7, 14, 21, 28. Only 4 are favorable. So the probability of an event is total favorable outcomes by total possible outcomes. It is 4 upon 30. You have to insert these numbers either here or in the bottom so that we can check easily. Next, a prime number. 2 is a prime number. 3 is a prime number. 2, 3, 5, 7, 11, 13, then 17, 19, 23, 24, 25, 26, 27, 28, 29 and 31. See any number left? 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. You have altogether 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the probability of an event equals favorable outcomes is 11. Total possible outcomes is 30. So the probability is 11 upon 30. So here in every case you have to identify what could be the favorable. Then you can easily get the ratio as its probability. Two unbiased coins are tossed simultaneously. As we know that when two coins are tossed, we have 4 possible outcomes. They are HH, HT, TH, TT. 4 possible outcomes. Find the probability of getting at least one head. At least one head is 1, 2 and least is that it can be increased. So 2 head also we can consider. So 1, 2, 3 are the favorable. Probability of event equals 3 upon 4. Then at most one head, maximum is one head. Further, there is no such condition. So we have maximum one head, no head also we can consider. Again, the probability of event is 3 by 4. At least, at most. Next. A coin is tossed 3 times. List all possible outcomes. We already listed there are 8 possible outcomes. Find the probability of getting all heads. All heads here you have HHS only one time. So its probability is 1 upon 8. Then at least 2 head. At least 2 head you have 1, 2, 3. So at least minimum it may increase. So you can include the 3 head also. So the probability is 4 upon 8. Question number 7. One card is drawn from well shuffled deck of 52 cards. Find the probability of getting a non-face card. You have out of 52 non-face cards are 40. So the probability is 40 upon 52. But don't write only the final answer. You have to write total possible outcomes in the denominator, favorable outcomes in the numerator. In the LHS, you have to write probability of getting, then write the final answer. If it is MCQ only, you can write the final. Otherwise, 3 marks means 3 set of conditions they will give up. Each carries 1. So the writing of the ratios in words than its numerical value is very, very important. A black king or a red queen. You have black king. We have 4 black king and red queen. You have 4 red queen. So together you have, 4 black kings. Here you have spade and club, and queens, red queens are in heart and diamond. Together it is 4 upon 52. Next question. A box contains 100 cards numbered 1 to 100. A box contains, so total possible outcomes. Total number of cards is nothing but total possible outcomes. In the question itself they have given it is number 100. Sometimes they won't give set of numbers from 1 to 99, 1 to 49. You have to get how many cards in between that, then you write its possible, total possible outcomes. Now, one card is drawn. Find the probability that it bears a single digit number. Single digit number is from 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the probability of getting single digit number is 9 upon 100. A number which is a perfect square. Which are the perfect square? 1, 4, 9, 16, 25, 36, 49, then 64, 81 and 100. These are all perfect square number which are in 1 to 100. So count it, then you will get favorable. Total possible outcome is 100. A number which is divisible by 7. 7, 14, 21, 28, 45, 35, 42, 49. Like that you have to proceed till 100, the multiples of 7. Like this. Okay, till 70, then 77, then 77 plus 7 is 84, 84 plus 7 is 91, 91 plus 7 is 98. All these will be the favorable. So total divided by total possible outcome as 100, that gives the probability of multiples of 7 or which are divisible by 7. Next, all the black cards are removed. All the black cards are removed from a pack of 52 cards. Out of 52 cards, you have 13 plus 13, 26 black cards. That is 13 from spade, 13 from club. 13 plus 13, 26. Find the probability of getting a face card. P of getting face cards. Since already 26 are removed, the remaining is 26 only. And you have face cards 3 plus 3. 3 from diamond, 3 from heart. Together you have 6. 6 upon 26. Next, red card. We have red card again 13 plus 13, 26 by 26. Red cards is excluding black cards. You have another 13 plus 13 red card together 26. So favorable is 26. Total possible is also 26. Its probability is 1. King. You have already 2 black kings which have been removed. Out of 4 kings, you have 2 from each. Black cards have removed. Another 2 from red you have to consider. Together you have only 2 kings of red. So your answer is 2 upon 26 because already 26 black cards are removed. Then, what about the question which I, a black king or a red queen? A black king you have 2, a red queen you have 2. It's correct only. Here, out of 26, 2 black queens are removed. The red queens from 26 leftover cards is only 2. And the possible outcome is 26. So, its probability is 2 upon 26. Next. Question number 10. If the probability, this type yesterday only I had discussed, if the probability of winning the game in a match P of E equals 0.08, what is the probability of losing? We write losing as not an event. Losing of game is not an event equals 1 minus P of E. That is 1 minus 0.0. Get the difference, you will get the final answer. Next, can 1.1 be probability of an event? What is your answer? Can 1.1 be probability of an event? Yes or no? Not an event, because probability of an event always greater than or equal to 0, less than or equal to 1. Here is the condition. Answer, justify your answer they given. You have to mention this relation. Since P of E, probability of an event, is greater than or equal to 0, less than or equal to 1. Therefore, 1.1 cannot be a probability of an event. A die is thrown once. That means rolling a die, you have 6 possible outcomes. 1, 2, 3, 4, 5, 6. Find the probability of getting prime number. Probability of getting a prime number when a roll 1, 2, 3, 4, 5, 6. Here they are not mentioned an even prime number. If it is even prime number, there is only one chance. It is just a prime number. So we write 1, 2, 3. 2, 3 and 5. There are 3 favorable out of 6. So the probability is 1 by 2. Is it clear? So now I will move on to the MCQ problems. Here comes the multiple choice question. You can answer, you give the answer. We will have the discussion over it, because after listening all the explanation regarding all types of conditions or the trial or the activity, now you are able to answer this MCQ question. Is it clear? First one. From a well shuffled pack of 52 cards, 2 black kings and 2 red queens are removed. That is 2 plus 2, 4 cards are removed out of 52. So the remaining cards are 48. The probability of getting face card. You have 2 king and 2 red queen. So you have total 12 face card. With that already 4 face cards are removed. So the probability of getting the face card is what you get? Yes, you already 4 removed out of 12 cards. You get 8 by 48. What is the answer? 1 upon 6, option A. Second one you can easily answer. The probability of a sure event is option A 0, option B 1, option C 1 by 2, option D -1. The answer is for a sure event it is 1. Next. Here comes one question like yesterday what I discussed about the bad eggs, like that here also. Bulbs, out of 400 bulbs, 400 bulbs is total possible outcomes. 15 found defective. So difference is 385 is good one or non-defective. Right. Now the condition, the probability of drawing non-defective or good one is 385 by 400. Simplify and give me the right option. 15 by 400, 3 by 400, 77 by 80, 77 by 400. What is the answer? So from the total number of bulbs, defective one if you subtract, the non-defective that is good one is 385. So its probability is 385 by 400. Yes, you are all correct. It is 77 by 8, option C. Instead of giving the number, you can mention option also and accept that also. Very good. Next. A die is thrown twice the probability of getting 5 at least one time. That means when a die thrown, you have a condition like this. I tell you, you have that is 1 5, 1 5, 2 5, 1 5, 2 5, 3 5, 4 5, 5 5, 6 5. Then 5 1, 5 2, 5 3, 5 4, 5 5, 5 6. So this you will get it when 6 cross 6 table if you put. There are total 12, 6 plus 6, 12 conditions, but 5 comma 5 is repeated in both the condition. So now we opt only excluding one at a time, that is 5 comma 5 only one time. So the favorable will be 11 and total possible will be 36. Is it clear? When you go through the table, you can find out 1, 5, 2, 5, 3, 5, 4, 5 like this. Here also 6 plus 6, 12. But this 5 comma 5 event is repeated 2 times. Considering one at a time, its favorable will be 11 and total possible will be 36. So the answer is 11 by 36. Fifth question. Just give me the option either A, B, C or D. We represent probability of an event. Yes, it lies between option A, option B, option C, option D. Yes, option C is the right answer. It is less than or equal to 0, greater than or equal to 0, less than or equal to 1. The probability of an event lie between the condition. Fine. Now to this also you can answer from the numbers 1, 2, 3, 35. A number is chosen. Find the probability. The number is a multiple of 7. You have 7 ones are 7. Then 7 twos are 14, like that. Maximum you have option multiples of probability. The number chosen is a multiple of 7. What is the answer? 1 by 7. Okay, 7 5s are 5 by 35. It is 1 by 7. Good. Next, seventh question also you can answer. A letter of English alphabet is chosen at random. Find the probability of getting a consonant. Taking off vowels A, E, I, O, U. The remaining is 21 out of 26 letters English alphabets. So the option B is the right answer. Good. Question number 8. All the red face cards are removed. When red face cards are removed, you have 6 red face cards. 52 minus 6. Then remaining, find the probability of drawing a queen. So you already face cards are removed, red face cards. You have black face cards, 2 black queen, 2 upon 52. Option A. Correct. Option A is the right answer. A bag contains number 1 to 49. A card is drawn, an odd number. What could be the odd number? Yesterday I think we have discussed from 1 to 49. The total is 49. We have selected the odd numbers with an AP condition. It was 25. So the probability is 25 by 49. Very good. You are all sure. Next, one card is drawn from a well-shuffled 52. The probability of getting non-face card. Option. Tell me the option. Option non-face cards. Face cards are 12. Non-face cards are 40. The last option 40 upon 52 is the right answer. Is it clear to you all? So that completes your probability chapter. Feeling easier is okay. No need of answering the worksheet as an assignment. You go through the question and try to answer in your notes is sufficient. This is a relax. Okay. I will announce as early as possible the next chapter what you are going to do. That is coming Monday. Monday you have the new chapter. Either I will take the geometry or from coordinate geometry or quadratic equation. We'll think that. Okay. So now this probability chapter is a relaxation period for you all. So easily digestible chapter. You can easily answer. But at least while answering in the notebook, try to write the condition favorable by total possible outcome. Have the practice of it. You have few more types of questions based on all these events. Once you know the events outcomes, you can easily understand that we discuss in the revision part. Okay. Thank you very much. Have a nice day. Meet you on Monday class. Thank you.